In this video, we are going to look at some special cases of systems of equations, and we're going to be using both your Lesson 3 and your Lesson 5 notes. We're going to start off with Lesson 5, and we can see we have a graph here. And if I have two lines that are like this, you can see their slopes are not the same. The slope of this one is +1. The slope of this one is -1. Anytime their slopes are not the same, they're going to intersect. You can see the intersection point right here. And the solution is going to be that point of intersection. So my x value is -2, my y value is -1, my solution is the point -2, -1. So when two lines intersect, you have one solution. But it's also possible for two lines to be parallel. And you can see the slope of this one is -1/2. Slope of this one is also -1/2, but their y-intercepts are different from one another. So when their slopes are the same and their y-intercepts are different, the two lines are parallel. Now, if the answer is the point of intersection, what do you know about parallel lines? Well, parallel lines never intersect. So in this case, we don't have a solution. There's no place where they intersect. So the solution, maybe you want to write none, maybe you want to write no solution, maybe you want to write there's not one. Anything that means that is fine. The important thing is when you take a test or a quiz, don't leave it blank. If you leave it blank, what that tells me is I don't know what the answer is, which is not true. It's not that you don't know what the answer is, it's that there is no answer. So make sure you make a point to say that. All right, now look at this one. The red line and the blue line are right on top of one another. That means that their slopes are the same and their y-intercepts were the same. Remember when they were parallel, the slopes were the same, but the y-intercepts were different. In this case, the slopes are the same and the y-intercepts are the same. Now the answer, remember, is the point of intersection. It's the point that they have in common. Well, how many points do these have in common? They have infinitely many points in common. So let me write that down. There are infinitely many solutions. Now, is it true that the answer is all real numbers? Could I write that? Does infinitely many mean the same thing as all real numbers? Okay, so think about that for a second. How about this point right here? Is that point in the solution of this system of equations? Nope. How about this one over here? Nope, that one's a no also. But every point that's on the line is a yes. So there are infinitely many points on the line. There are infinitely many solutions. But there are also infinitely many points not on the line. That's why you cannot answer this with all real numbers. There are infinitely many solutions, but not every point is going to be a solution. Okay, let's look at what these look like algebraically. We've looked at what they look like graphically. Let's look at what they look like algebraically. So if you go back to your Lesson 3 notes and look at the back. We already filled out the front page. We skipped several on the back, however. All right, let's look at this one. It says solve for x and y by the method of your choice. So I look and I see that none of my coefficients are 1 or -1, so I am not going to choose substitution. I'm going to choose elimination. I can cancel these out if they are opposites of one another. So I'm going to put this one in parentheses and I'm going to multiply by -1. I'll distribute a -1 all the way across that because I need for my y coefficients to be opposite one another. +2 and -2 are opposites, so they cancel out. On my x's, 8x minus 7x makes 1x, or just plain x, and 30 minus 24 is 6. Okay, so I have an x value. I also am going to need a y value. So remember, it doesn't matter which one you substitute into. So I'll take this one and I'll substitute into that second equation. So 8 times 6 plus 2y equals 30. All right, let's see how we can do here. 8 times 6 is 48. Trying to get y by itself. So I'll subtract 48 from both sides. Those are opposites. They cancel out. Dividing both sides by 2 and I get -9. So my final answer is the point 6, -9. Okay, oops, think about the three types that we had. I don't know why my pen just stuck there. The three types that we had, this one, will the two lines cross? Will they be parallel, or will they be the same line? Well, look, we have one solution, so therefore it must be this type. The two lines crossed each other, and we have one solution. Okay, let's go on to another one. Skip down a little bit till you see where it says special cases. All right, so I look at my coefficients here. Again, I do not see anything that is a coefficient of 1, so I'm going to choose to use elimination. All right, let's see what we have. The signs are opposite each other. If I can make the numbers opposite each other, then I'm going to be able to cancel out the x's. So let's multiply that top equation by 5 and the bottom equation by 2. There's no reason to multiply by a negative because the signs are already opposite one another. All right, so in the bottom one, distributing that 2. All right, and then I'll add straight down. Those cancel, those cancel, those cancel. Okay, so think about what happens when you cancel. Positive 10x and negative 10x. What do they actually add up to be? They actually add up to be 0. The reason why they cancel is because they're 0. So really, right here, I have 0 and 0. Put those together and get 0. And on the right-hand side, 30 minus 30, also 0. So then you have to ask yourself, 0 equals 0. Is that a true statement, or is that a false statement? Well, 0 equals 0 is a true statement. So anytime you have a true statement, anytime something works out to be the same number on both sides, it doesn't have to be 0, it just has to be the same number on both sides. I might have 7 equals 7 or 5 equals 5. And if that's true, if I have a true statement where two things are equal to one another, then this is going to be the kind where there are infinitely many solutions. In this case, if I were to solve both of my equations for y and get them ready to graph, I would see that they are exactly the same line. They have both the same slope and the same y-intercept. Okay, let's look directly underneath it at this one. So here I have some coefficients of 1. I haven't practiced with substitution, so let's practice that. I'm going to choose to solve for x. So that means I need to get x by itself, subtracting y from both sides, x equals negative y plus 4. Okay, now you remember in the substitution, I have to take this and I substitute it in for x in the other equation. So I'm going to put negative y plus 4 in place of x. All right, I'm going to distribute my negative 2 right here. So I'll get positive 2y minus 8 minus 2y equals 10. All right, let's combine like terms. Positive 2y and negative 2y. Those are opposites. They cancel each other out. And so what I'm left with, negative 8 equals 10. Okay, so now we're going to ask ourselves the same question. Is this a true statement, or is this a false statement? Well, is negative 8 the same thing as positive 10? No. So this is a false statement. And again, it doesn't matter that it's negative 8 and 10. It could have been 18 and 0. It could have been negative 18 and 47. As long as they're different from one another, it's a false statement. And if I get a false statement, the answer is no solution. So that means if I tried to get these ready to graph, I would have the same slope but different y-intercepts, so they would be parallel to one another. They would never intersect, so the answer is no solution. Okay, let's go back to Unit 2, Lesson 5 notes where you see example 1 right there. And it says solve by graphing. We've practiced elimination, we've practiced substitution. Let's practice graphing. Okay, if I want to graph this, I need to get y by itself on both of them. So on this first one, I'm going to need to add 2x to both sides. All right, positive 2x and negative 2x are opposites of one another. Those are going to cancel out. And I get 3y equals 2x minus 9. All right, dividing by 3 on both sides, 2/3 x minus 3. Okay, so let's remember how to graph that. First thing I'm going to do is put a dot on my y-intercept at -3. Sorry, I'm aiming the best I can on this little screen with my finger. Sometimes it works better than others. Let's see. So 1, 2, 3, -3 is right here. All right, and then from that point, I'm going to count up 2 and right 3. And I have my next dot right there. So remember, when the slope is positive, you're going to count up and right. And then I'm going to connect the dots. So connecting the best I can here. Oh, that is a terrible line. Try to use my finger instead of the cursor. Okay, let's try the other one. So I'm going to do this one over here. And I need to get y by itself. So let's subtract x on both sides. Again, those are opposites, so they cancel out. -x plus 2. Okay, so that means I'm going to go to the y-intercept of 2. That means I go to 2 on the y-axis, and then I'm going to count down 1 and right 1. Right? If my slope is negative, it needs to be going this way. So down and then right, or I could go up and then left. That would be fine. But I cannot go down and also left, because that would be negative divided by negative, which is actually positive. So I want to be careful. I can go up and left, or I can go down and right. Okay, so let's connect the dots on those, aiming the best I can there. All right, and then my point of intersection. So you guys have rulers in your buckets that you can use so that you can get these very, very accurate, and you can see the point of intersection right here. It's the point 3, -1. Now you would want to, especially with graphing, you want to test that and make sure that you got the right point, because there's a lot of room for human error here. We can also practice that on our calculator. So I have it already graphed on the calculator here. So to find the intersection point, remember we do second trace. And I'm going to pick number 5, which is intersect. Okay, is the blue one my first curve? Well, yes, it is, so hit enter. Is the red one my second curve? Yes, it is, so hit enter. And now it wants me to guess, so I'm going to move my cursor as close as I can to that point of intersection right there. And I'm going to hit enter one more time. And so there's my intersection, the point 3, -1, which is what we got when we did it by hand. So it's good that we have the calculator here to verify, but make sure that you are able to graph these. For delta math, you're going to have to be able to graph the y-intercept and then count the slope. Graph the y-intercept and then count the slope. And also, if I ask you to graph it by hand on the test, those are the points that I'm going to be checking for. Typing it in your calculator and estimating is probably not going to give you the right answer for that on the test. Make sure that you are able to graph those properly. And we will finish the rest of the lesson 5 notes in class so that we can practice with these together before you guys have your next assessment.